Welcome to Inventor Camp Professor. I'm Sydney, your Inventor Camp Professor, with one of hundreds of online video tutorials available free at www.inventorcamp.com 24 hours a day, 7 days a week. In this session, we'll be showing you our new operation called face. We'll start by going into our operation of turning, and as you can see, we have three new operations. We have a new operation called face, we have a new operation called angled grooving, and we have one called cutoff. Let's start by going into face. Now let's just take a look for a moment at the interface. As you can see, the interface now looks a lot cleaner than it was in the previous versions. We also have diagrams describing exactly what each thing does. For example, in the technology page, as we are right now, you can see that we are doing a face cut according to the diagram we have over here. We also have here showing us the material to be cut, whether it be in the positive direction or in the negative direction. Let's go into technology just for a moment also. And as you can see, if I were to click into this field over here, you can see that we're talking about our offset. Over here, retreat distance, equal step overs, and so on and so forth. Let's go back now into geometry. We've also added the option of submachines. This allows us to work on different submachines according to the type of machine that we're working on. For example, in this particular machine, we're working on an Integrex where we have a main spindle and a sub spindle. So the main spindle, we're talking about the main spindle plus the B-axis, and the sub spindle would be the back spindle together with the B-axis. All of this is defined in our machine ID. Let's take a look for a moment at the machine ID, and I'll leave the operation just for a moment. If we were to look in our machine ID, you'll see that we have here our submachines. For example, we have our main spindle, which is based on our turret spindle plus the main spindle, and our sub spindle is based on the turret spindle and the sub spindle. If we were to go down further over here, we can actually click on our main spindle, and we can see also over here that it's turret spindle and the main spindle. We've given it the name of main spindle. And the same thing with sub spindle. We have here our turret spindle and our sub SP, or also named sub spindle. Now let's go back into our operation of face, and we'll start actually working this operation. Now we'll be working with our main spindle in this particular case, and we'll be cutting from the positive Z side. In addition, we've also added the option of edit geometry, just like we have in our milling operations. We'll take a look at that in a few moments. Let's first start defining our geometry, and I'd like to actually work on this face over here itself. So I'll click on define, and I'll click on this line over here and accept that chain. Now, in modified geometry, we have our start extension, and we also have our end extension. What we've added here is the option of auto extend to stock. We can either put a value of how much we want to extend our stock, say 10 millimeters, as shown over here, or click on auto extend to stock. This will automatically extend the toolpath all the way up to the stock itself, eliminating the need for guesswork as to how far we have to go out. We also have the option here of working tangential to our geometry or linear. If we work linear, we have the option of putting at what angle do we want to approach. I can have it at 0, as shown over here. I can have it at 30. I can have it at any angle I want. In this particular case, though, I'll be using the option of tangential. We also have the option of using end extension and extending it also automatically to the end of the stock. In this particular case, the center of the part. Now, let's choose our tool. In our tool area, we'll go to select, and I have a tool over here which I will be using for cutting this part, and I'll choose that tool. Now, as you can see, the tool is not exactly lying in the position that we need. However, we do have a diagram here showing exactly what position we'd like to have our tool. And in this particular case, I'd like to have the tool in this position over here. So I'll simply click on this diagram, and you can see the tool has turned. In addition, we've also cleaned up this entire area over here. And instead of all the buttons we used to have here, we put it in different tabs on top. For example, the data of the tool, the origin position, coolant, tool change position, all of this has been moved up here. Now, let's go into our technology field. And as you can see, we've actually made it very easy to understand. We can actually work from our stock area, where automatically we'll start working from the stock itself, or we can do target extend by, where we're not actually looking at the stock itself. We're just going to choose a specific value, and I'll leave it at stock. We can work from the front or from the back, as shown over here. We have our direction, either one way or zigzag, and we have our roughing options over here. In addition, we have our step over of whatever value we want, and I'm going to have it at 0.3 millimeters. What we've added here is final steps. What our final steps actually does is that when it gets close to the actual offset that we have set over here, it'll give us a final step of whatever value we put down over here. Say, for example, 0.2 millimeters, and have that doing it one time or several times. I'm going to leave it at doing that at one point. We'll have our offset set at 0.05 millimeters, and we'll do a finish cut. Now, let's take a look at our simulation for a moment. As you can see, we have our tool path done here, and if I zoom into this area over here, you can see that we have our step overs, as shown over here, plus we have our final step. Now, here we have our finish cut, and you'll note that our finish cut has absolutely no lead in at all. Let's go back now to our operation, and what we've done now is added in our links the option of finish lead in and finish lead out. For example, I can go into finish lead in and click on tangent and have it go in on a tangent of, let's say, 20 millimeters. Now, I know 20 millimeters is a large amount, but I've actually written this in so that we can actually see it a lot easier in our simulation. Let's go now into our simulation again. And this time, if I run my simulation, you'll see that the final toolpath has its own lead in, and we have now full control of that as well. For more InventorCam Professor tutorials, please go to our website, www.inventorcam.com, and look under the tab called InventorCam Professor. Thank you for joining us on InventorCam Professor. Take care and have a nice day.